We are going to move slightly on from the quadratic formulas and we're going to go into the inequalities but still using quadratics. So we're going to be able to solve quadratic inequalities, solve polynomial inequalities of degree 3 or greater, and solve rational inequalities. A quadratic inequality is the same as a quadratic equation except we're utilizing greater than, less than, greater than or equal to, and less than or equal to. If I'm looking at a graph and I want to solve a quadratic inequality graphically, I'm asking myself, where is this value going to be greater than 0? The way I'm going to approach that is like solving if it was equal to 0. I'm going to find the x-intercepts. I can do that by factoring the quadratic formula or completing the square. This does factor, so I get my x-intercepts are -2 and -4. Which should make sense because they're right here. I want to know what y values are going to be greater than 0, but still belong to that graph. If you notice the graph of the x values, the values that are between -4 and -2 results in y values greater than 0. So I'm going to go from -infinity to -4, and that's describing this area on the x-axis from -4 as it decreases, and then from -2 to infinity where the graph is greater than 0. So when I'm looking between -4 and -2, between these two numbers, my graph is actually negative because the y values are negative. But if I look at the interval, it's positive all the way to -4, and it's positive all the way to -2, which is where these intervals come from. Again, if I have the graph, I'm going to find the x-intercepts by factoring, completing the square of the quadratic formula. If I want to know where they're less than 0, that's where the graph is below the axis. It is below the axis between -4 and -2. So that would be this notation. This would be -4 is less than, x is less than -2. It would not be equal to because this symbol is not equal to. So it's always parentheses based on that symbol. Here I have greater than or equal to. That is going to change the notation that I use. I'm going to solve the equation just like it was a regular problem. I could factor, I could complete the square, I could do the quadratic formula. Once I have those values, I'm going to divide my number line up. And I'm going to say, well, I have all the x values from -infinity to -2. Then I have values from -2 to 0.5 and 0.5 to infinity. I want to know where this is greater than or equal to 0. So I divide it up into 3 intervals because I don't have a graph handy. I'm going to choose a number from each interval, and I'm going to see what happens. When I choose from the first interval, I am getting greater than or equal to 2. That is okay. It's greater than or equal to 0. So I get 9 is greater than or equal to 2. Yes. Then I'm going to pick x equals 0 and plug it in. I do not get a true statement, so I can X out that interval. I'm going to pick 1. I plug 1 in, I get it true. So my interval then is from -infinity, and it's always a parentheses on -infinity, guys, to -2. It's a bracket because I had the equal to on there. Then it's going to be from 1/2 to infinity. That infinity should have a parentheses on it, so that is a typo in the slide. So we should have a bracket around 1/2 and a parenthesis around the infinity. That's a mix-up. So if I was going to write this down in steps, this would be how I describe it when I'm not given a graph. And we do have the wonderful ability to graph a lot of things with our calculators, but we want to stay away from that unless we're specifically told to. So this is another example, But I wanted to highlight here that 18 does have to come over. Then I'm solving it like normal, and I get an x value. But because it's an inequality, I set up my number line, I set up my intervals, I choose a value from each interval to see if I get it true or false. The only interval that is true is interval B, which if we go back, interval B is between -3/2 and 6. So that tells me that my interval is -3/2 or 6. It has the equal to, so it's going to be a bracket. And then I would shade. These are some other additional examples. I suggest pausing the video, working through these, then coming back and checking your work. You need to FOIL both of them. But what's going to happen when you FOIL it and you get it all on one side and you use the quadratic formula is that you're going to get a negative under the square root, which we know can't happen with a real answer. You could also eyeball this and say, well, I'm never going to get a negative number out of squaring something. So this is not possible for that. To get -2 to be equal to. So then I'm going to say, okay, well, greater than. Let's think about greater than. Well, if I'm doing greater than, I have 3 minus 2, and I'm squaring it. When I square something, it's going to be a positive number always. So it's always going to be greater than -2. So some of these questions, you may have to think your way around them, because if you solve them traditionally by hand and launch directly into it, you might miss a problem. And then in part B, I have the opposite situation where I'm squaring something, it's never going to be less than -2. So there's nothing I can do there. To solve polynomial inequalities of degree 3, meaning a cubic, this is where it gets real, y'all. We have to FOIL twice. So I have to do the first binomial times the first binomial, which isn't too bad, it's FOIL. But then I have to distribute an x to all of those terms, and then a 4 to all of those terms. So now I have 6 terms. That's a lot. But what I can do to shortcut that process is this is factored into binomials. If I want to know where it's greater than 0, I can start with where it's at 0. And I can solve each one. So the instinct is to FOIL this out. But because it's already factored for us, we're actually over halfway through the problem. I'm going to set up my intervals just like I did with quadratics, but I have more intervals. I'm going to plug in and see what is true and what is false. My intervals that were true are the ones that are shown. It was not equal to, so I have between -4 and -3.5, or -1.5. And then I have from about a half over, those are going to be my intervals. Where is the U coming from? Well, the U is an AND statement. So I'm saying this answer and this answer. So to solve a rational inequality, I have a series of steps. Definitely pause the video and copy this down. Now, this is where some students are doing some crazy things. I want to go ahead and get everybody on the left-hand side. That's really essential. Then I want to get a common denominator. Some people want to multiply by x minus 4 and cancel it out, but when I have 0 and I'm multiplying it by x minus 4, I'm losing a root. So that's why I need to go this method. Once I get things fully simplified, then I can start looking at this and saying, well, if I look at the top of a fraction, any number at the bottom when the top is 0 is going to make this true, because 0 divided by any number is going to be 0. So I'm going to set up those intervals based on the values I found for x, and I'm going to try them out. I get 2 intervals are equal from that interval method. So if I'm looking for where it equals 0, that's really helpful to me because I can definitely plug it in. But I'm creating my interval by looking at where those values are that I just found. So I have 14 over 3 makes the numerator 0, and 4 makes the denominator 0. So when I set up those intervals, that's what I'm doing. I'm using those values. And then there's my solution. Here's my number line, shade them in. Here I'm going to follow the same thing. I'm going to get that 5 over, then I'm going to get a common denominator, and now I can look at where is the bottom 0 and where is the top 0. Well, negative 4x plus 7 would be 7 over 4. X minus 1 would be 1, so then I can set up my interval. And I like showing the interval first, guys. So I can set up my interval, and I can plug in numbers and check. Numbers that are over here would be 0. Numbers that are between would be 3/2, and then this is anything bigger than or equal to 2. So this is definitely a video you may want to go back and watch a second time to follow along with me and be able to solve those inequalities.